Carboxylic acids are what occur when you have an alcohol group and an aldehyde group reacting. When they react, you get both the carbonyl group, present here, and the alcohol group, the hydroxyl group, present here. Together, they are called a carboxyl group and are frequently referenced as COOH, commonly referred to as a Cu radical, COO. Carboxylic acids are acidic for the same reason that all our other acids are acidic. They will donate a proton, and in this case, it is the proton that is part of the hydroxyl group making up the carboxyl group. Again, we have the indication here that it can go on the end of any carbon chain. But that's just it. By the nature of having COOH, it is always at the end, much like the aldehydes. Now we can name carboxylic acids by, of course, denoting that they're acidic with the word acid terminating the name. And then we're going to say anoic. Again, I like to remember this because carboxylic acids end in ic anyways. And the O is just there to remind you that there is a double bond to an O. When looking at organic compounds, in particular carboxylic acids, I always note right away that there are two interesting areas, the OH and the double bond O, always on the same carbon. This immediately brings to mind that carboxyl group. Right away, I know it's going to be acidic in nature, so it's going to be an acid with that proton being donated, and that I will have to end in anoic. I will, of course, count the backbone carbons, just like before, 1, 2, and get eth. In this case, this structure is called ethanoic acid. We can name other carboxylic acids quite easily using the same methodology. Again, looking at for what's interesting in the compound, the fact that we have a carbon attached to one hydroxyl group and one carbonyl group, making a carboxyl group, brings to mind immediately an acid that is going to end in anoic. Again, count the number, starting with the interesting group as the lowest number, must be number 1. I'm going to count away to get the longest continuous chain. 1, 2, 3, 4, 5. Now my root name is going to be pentanoic acid, but this time I also have some side chains that I need to indicate. Chloro, so they're halogens, so I know it's going to be dichloro since there are 2 of them. And of course I have to indicate the number 1, 2, 3, 4. And while it's a little redundant, we do repeat it. So 4,4-dichloropentanoic acid. Now sometimes, actually, quite commonly, you get aromatic carboxylic acids. In this case, we see the aromatic structure here with the benzene ring. And then we see a carbon chain coming off of it, double bonded to an oxygen, and another oxygen hydrogen. So again, that's a COOH. In this case, you can name it benz for benzene, and then simply oic acid. I hope you enjoyed our last lesson for today. It is on carboxylic acids and a combination of alcohols and aldehydes forming a carboxyl group, ending in acid, and having the suffix anoic.